Good morning, students. In last lecture, we have studied what is capacitor, what is effect of dielectric in capacitor. Now we will study connection, combination of capacitors. Like in standard 10, we have studied series and parallel connection of resistor. In this chapter, important topic is capacitors connection. First of all, we will study capacitors in series connection. What is a series connection? How from figure you can identify it is a series connection. See, here, as shown in figure, capacitors C1 and C2 are combined in series. Capacitor C1 and capacitor C2, they are combined in series. The left plate of C1 and right plate of C2, they are connected with battery. They are connected with battery. Okay, so see, from this we can say, as this C1 plate is connected with positive terminal of battery, positive charge Q is on this plate. This plate is connected with negative terminal, so that is negative minus Q charge on this. So see, plate of C2 are connected to terminals of battery and they have charges plus Q and minus Q respectively. Clear? Okay. This plate is connected with positive terminal, this plate is connected with negative terminal. So on this plate plus Q charge, on this plate minus Q charge. This results in electric field in this region here, in conductor connecting to capacitors. In conductor connecting to capacitors. And due to this electric field, in this conductor charges will flow until both C1 and C2 they become chargeless. Means total charge on them becomes 0. When total charge becomes 0, here on C1 this plate charge is plus Q. So if on this plate it has minus Q charge, and on C2 negative charge minus Q, so on this side if plus Q charge flows. Clear? So due to electric field produced in conductor connecting to capacitors, charges flow until total charge on capacitor becomes 0. Total charge on capacitor C1 and C2 both become 0. So we can say in series connection, charges on capacitor are same. Charges on capacitor are same. On this capacitor, what is charge? Okay. Charge on capacitor means charge on positive plate. Charge on capacitor means charge on positive plate. So on this capacitor charge is Q. On this capacitor charge is Q, and that is supplied from this battery. That is supplied from this battery. Okay. So in series connection, first thing you have to remember, okay, charges are same on each capacitor. Charges are same on each capacitor. How to remember this series connection? See, these two capacitors are connected like end to end. Two ends of capacitor, first and second. Negative plate of first capacitor is connected with positive plate of another. If we have another capacitor, then negative plate of second capacitor is connected with third positive plate of third capacitor. Okay, so it is how we identify what is series connection. Another way to find series connection, it is battery. From battery charge is flowing. There is only one path. There is only one path, and these capacitors are on one path. So we can say they are in series connection. Okay. Now its capacitor is C1, charge on it Q. Capacitor C2, charge on it Q. I am assuming that potential difference between two ends of first capacitor is V1. Potential difference between ends of or between two plates of second capacitor is V2. Then the total potential drop V across the combination is sum of potential drops V1 and V2 across C1 and C2 respectively. That is V is equal to V1 plus V2. Students, now you may ask, sir, why this relation? How to obtain this relation? We will obtain this relation in chapter number 3 after Kirchhoff's law. After Kirchhoff's law, right now you have to remember, okay, V is equal to V1 plus V2. For series connection, V is equal to V1 plus V2. For series connection, V is equal to V1 plus V2. where V is voltage, potential drop across combination, V1 across first capacitor, V2 across second capacitor. Charges are same. If charge on this capacitor I say Q1, on this capacitor Q2, then this Q1 is equal to Q2 is equal to Q, that is supplied from battery. Okay, so now how to write this equation? See, V is equal to V1, I can write Q upon C. How? Because you know this equation. C is equal to Q upon V. So V is equal to Q upon C. So Q upon C1 plus Q upon C2. Because in series connection, charges are same. So here I have QP. Clear? Now if you take this Q common, okay, and if you bring this Q in denominator, then you can write V upon Q is equal to 1 upon C1 plus 1 upon C2. Now what we have to find? We have to find effective capacitance of this combination. Okay, if these two capacitors are replaced by only one capacitor, then how to replace? See, I have assumed. Okay, if these two capacitors are replaced by only one capacitor, having capacitor C equivalent, what is charge? Q. Voltage applied V. What is charge U? So, see, if you make relation for this capacitor, if C equivalent is effective capacitance of combination, then from this figure you can write C equivalent is equal to Q upon P. So here this V upon Q you have to replace by 1 upon C equivalent. Then 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2. It means if C1 and C2 they are connected in series connection, then what is its equivalent capacitance? 1 upon C1 plus 1 upon C2. 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2. You have to remember three relations. In series connection, charge on each and every capacitor is same. V is equal to V1 plus V2. 1 upon C equivalent is equal to 1 upon C1 plus C2. You have to remember these things to solve questions. Now, if you are given n capacitors, then 1 upon C equivalent is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3 plus 1 upon Cn. General equation. If you are given n identical capacitors, identical means capacitance same. So 1 upon C equivalent is equal to 1 upon C plus 1 upon C dash dash dash. So it will be n upon C. And C equivalent is equal to C upon n. Clear? Again, in series connection, all capacitors are connected on one path. Charge flowing from battery is not distributed. Charge flowing from first capacitor, same on second, same on third, same on fourth, same on fifth. Clear? If there are different parts, then the charge is distributed. Here there is only one part, so charges are not distributed. Clear? Pause your video, write down from bottom. Okay, now we will see capacitors in parallel connection. See, again, as shown in figure, capacitors C1 and C2 are combined in parallel. Now see what is parallel connection. See, this capacitor C1, two ends. Another capacitor, two ends. So if capacitors are connected such that their one end is common, another end is also common, means capacitors are connected between two common points. Capacitors are connected between two common points. If I say it is point A and it is point B, then we can say capacitor C1 is connected between AB. Capacitor C2 is also connected between AB. So if two ends of capacitors are common, we can say such capacitors are connected in parallel connection. Okay, what is another way? See, these two capacitors are connected in parallel along with this supply, having voltage V and charge flowing from it is Q. See, if I say charge is flowing, then from this point, this charge gets divided. This charge gets divided into capacitors C1 and C2. Clear? So see, in this case, charge coming from this supply is divided into branches. Okay, so we can say these two branches are in parallel. Here charge gets divided. So I am assuming charge on this capacitor C1 is Q1 and charge on this capacitor C2 is Q2. Another thing, see, this point A is connected with this positive plate and this positive plate. And this point B is connected with negative plate and negative plate. Clear? Because these both plates are connected with positive terminal. These both ends are connected with negative terminal. Okay. Now, in parallel connection, again from Kirchhoff's law, you have to remember, in parallel connection, see, AB, this capacitor is connected between AB. This capacitor is also connected between AB, and this potential difference is applied between points AB. Then in parallel connection, potential difference is applied across both capacitor is the same. V1 is equal to V2 is equal to V. If I say potential difference for this capacitor is V1, for this capacitor is V2, then this V1 is equal to V2 and is equal to V. That is a supply voltage. So here you have to remember potential difference PD remains same. Clear? Okay. V1, V2 is equal to V. If I say supply voltage is 100, then what is potential difference between first capacitor? 100. What is potential difference between second capacitor? 100. Clear? Okay. Now how to obtain second relation? See, charge Q is flowing from this cell and it is divided into two parts, on this part and on this part. I have assumed here on this capacitor charge is Q1, on this capacitor charge is Q2 according to law of conservation of charge. Initial charge is equal to final charge. Okay, so Q is equal to Q1 plus Q2. Q is equal to Q1 plus Q2. Now I can write Q1 is equal to, again we know relation, C is equal to Q upon V. So Q is equal to C. So Q1 is equal to C1V. Q2 is equal to C2V because potential V1 is equal to V2 is equal to V. Clear? Now again, if I want to replace these two capacitors by only one capacitor having capacitance C equivalent with same voltage supply, with same supply charge, then what is the relation between these three quantities? Again, C equivalent is equal to Q upon V. So Q total charge is equal to C equivalent into V. This total charge Q is equal to C equivalent into V is equal to C1V plus C2V. V cut, then C equivalent is equal to C1 plus C2. Clear? Again you have to remember three equations. For parallel connection, potential difference is same. Charge gets distributed, so Q is equal to Q1 plus Q2. C equivalent is equal to C1 plus C2. Clear? So what is difference between series connection and parallel connection? That you have to remember. In series connection, charge on each capacitor remains same. V is equal to V1 plus V2. 1 upon C is equal to 1 upon C1 plus 1 upon C2. In parallel connection, potential difference across each capacitor remains same. Q is equal to Q1 plus Q2 and C equivalent is equal to C1 plus C2. So it is difference between series and parallel connection. Okay. Now for n capacitors in parallel connection, C equivalent is equal to C1 plus C2 plus C3 plus raised to plus so on. And if you are given n identical capacitors, identical means again capacitance same. So C equivalent is equal to C plus C plus C plus C raised to plus C. Okay, then C equivalent is equal to NC. Clear? Okay. Now we will obtain one general result. See, I have taken one example. C1 is equal to 6 microfarad. C2 is equal to 4 microfarad. For series connection, what is equation? 1 upon Cs is equal to 1 upon C1 plus 1 upon C2. So Cs is equal to C1 C2 upon C1 plus C2. 6 into 4 upon 6 plus 4, 24 upon 10, 2.4 microfarad. Yes, that is equation. For parallel connection, Cp is equal to C1 plus C2, 6 plus 4 is equal to 10 microfarad. Now you may ask, sir, what is result? What is conclusion? C1 6, C2 4. In series connection, equivalent capacitance is 2.4, less than each capacitor. Less than each capacitor. Yes. And in parallel connection, Cp is equal to 10 microfarad, greater than each capacitance. So it is result. It is result. Okay. In series connection, equivalent capacitance is smaller than smallest among combination. And in parallel connection, equivalent capacitance is greater than greatest among combination. Yes, you have to write these two statements, repeat your video and write down in your notebook. Okay, see some questions based on series and parallel connection. Exercise 2.6. Three capacitors, each of capacitance 9 picofarad, are connected in series. First question, what is total capacitance? Question B, what is potential difference across each capacitor if the combination is connected to a 120 volt supply? See here you are given three capacitors, each of capacitance 9 picofarad. So I can write C1 is equal to C2 is equal to C3 is equal to C. Means these three are identical capacitors. Yes or no? Yes. Okay. So in series connection, if you write what is equation? See, 1 upon Cs is equal to 1 upon C1 plus 1 upon C2 plus 1 upon C3. But we know that these three are identical capacitors. So we can directly write it is 3 upon C. Yes or no? And therefore Cs is equal to C by 3. Means it is 9 by 3. So therefore Cs is equal to 3 picofarad. It is your first answer. Any doubt? Okay. Now what is second question? What is potential difference across each capacitor when the combination is connected to 120 volt supply? First capacitor, second, third. What is voltage supply? V is equal to 120 volt. Yes or no? Yes, it is. Okay, see, we have to find V1, V2 and V3. How to find this? See, you can find this with the help of two methods. First of all, original method. What is original method? See, equivalent capacitance Cs is equal to 3 picofarad. Yes. Total capacitance is 3 picofarad. What is voltage? 120 volt. What is voltage? 120 volt. So what is charge supplied from battery? Charge supplied by battery is equal to Q is equal to CV Cs into V. What is value of Cs? 3. What is value of V? 120. Okay, 12 into 3. It is 360. It is pico, so I can say it is picocoulomb. Any doubt? Any doubt? Okay. So what is charge supplied from this battery? It is 360 picocoulomb. Now in series connection, we know that in series connection charge is same. Okay. In series connection, charge is the same. Charge is same. So therefore Q is equal to Q1 is equal to Q2 is equal to Q3 and is equal to 360 picocoulomb. Any doubt? So how to find potential difference between first capacitor? Potential difference for first capacitor. For first capacitor, V1 is equal to, we know equation, C is equal to Q upon V, then V1 is equal to Q1 upon C1. What is value of Q1? 360. What is value of C1? C1, yes it is 9. Yes it is 9. So it is 9 into 4, so we can say it is 40 volt. Similarly, you have to find V2. V2 is equal to Q2 upon C2. V3 is equal to Q3 upon C3. Yes, you will get one interesting result. Each and every answer is 40 volt. Each and every answer is 40 volt. See, it is method. With the help of this, you have to write in boards. How to write in very short. See, total supply is 120 volt. You have to find V1, V2 and V3. In series connection, charge is same. Yes or no? In series connection, charge is same. Here capacitance are also equal. So if charges are same, capacitance are equal, okay, then we can say potential difference are also equal. And if you divide this 120 equally, then 40, 40 and 40. Clearly. Clear? Okay. But in words, you have to write like this. Okay. Complete V2 and V3. Next question. Exercise 2.7. See. C1 is equal to 2 picofarad, C2 is equal to 3 picofarad, and C3 is equal to 4 picofarad. They are connected in parallel. Okay. First question, what is capacitance? Very simple. Cp is equal to C1 plus C2 plus C3 for parallel connection. It is 2 plus 3 plus 4. 2 plus 3, 5 plus 4, 9. It is 9 picofarad. Simple. Okay, now what is second question? Second question is determine charge on each capacitor if combination is connected to 100 volt supply. C1, C2 and C3, they are connected with 100 volt supply. Okay, now in parallel connection, we know that in parallel connection, potential difference is same across each and every capacitor, across each and every capacitor. So how to write? V1 is equal to V2 is equal to V3 is equal to V, that is supply voltage, and it is 100 volt. And it is 100 volt. Clear? Okay. Now how to find charge on first capacitor? Charge on first capacitor. Okay. Q1 is equal to C1 into V. Yes, you can write C1 into V1, but V1 is equal to V. So Q1 is equal to C1V. C1, what is C1? It is 2 picofarad. And what is V? It is 100. So it is 200 picocoulomb. It is 200 picocoulomb. Any doubt? Okay. Similarly, what is charge on second capacitor? What is charge on second capacitor? Q2 is equal to C2V. What is C2? It is 3 into 100. So is equal to 300 picocoulomb. Okay. What is charge on third capacitor? Q3 is equal to C3V. It is 4 into 100 is equal to 400 picocoulomb. Okay. Clear? Now see what is effective capacitance? 9 picofarad. If you replace these three capacitors by only one capacitor, having C equivalent is equal to 9 picofarad. Supply voltage is 100. Then what is total charge Q is equal to? What is total charge Q is equal to? Yes, it is C equivalent into V. Means 9 into 100 is equal to 900 picocoulomb. Add this. 200 plus 300 plus 400. You will get 900. So with the help of this method, you can verify your answer. You can verify your answer. You do not have to write this. Okay, it is just for verification. It is just for verification. Because in parallel connection, we know that what is relation of charge? Q is equal to Q1 plus Q2 plus Q3. So yes, Q is equal to Q1 plus Q2 plus Q3. This relation holds here. Clear? Pause your video and write down from bottom.